just give me an OK. Okay, so as you can see here, we have these two types of XML files. One I usually call the parser and serializer test because they test the parsers and the serializer. And they do it by sort of like, they just have a look at the file, and these are then the test cases. And a test case, it just takes this. This is a hexadecimal stream representation of a byte array. So it takes this, converts that into a byte array, feeds that into the TP packet IO class and says parse this, and it will output a Java data structure. What happens then is I use Jackson to serialize that back to XML. And that is then compared with what I have here. So if I parse this, this is sort of what the Java object structure looks like. So I have this TP packet, and it has a property called payload that is of this type. Then it has a list of parameters, each of these different types, with a property again, and that's of this type, and so on. What it does after parsing this, it compares the output with what it is expected to be. And then it serializes the object it parsed again and compares the output byte array with this one. So it's a full round trip. So you can see that it is able to parse this and is able to serialize this object correctly. These are pretty simple tests. The little more complex ones are, I always name them integration tests in the end. And that's when that's what you need if you want to test the complex logic of a driver. So in this case, if you want to use an S7, you always have to create a connection first. So this is what happens here in the setup part. So you can see now it's an outgoing PLC message. So the test suite will expect PLC4X to try to send this. It checks that it matches what it expects. If that was okay, then an incoming message would come. That would be what the PLC would send as a response to the above package. Before feeding it into the system, it's sort of like checked, is it sort of like, no, it just takes this data structure and serializes that as a byte array and just feeds that to the driver. So after that, it would expect that the driver again sends something out during the next connection level. So I hope you get the idea how this generally works. So you mainly you just say what you shove in on the API level, and then you just sort of like define what the driver sends to the wire and receives from the wire. So if we go down, the setup is a little complex. So here we have a test case. So we're just doing a single read request. So the test suite would now expect the connection is established and is alive. And now a user sends an API request. So he's just sending a simple query for a Boolean value. So as soon as the driver got this request, we would expect this particular driver to send this packet. So it's checked the same way the parser serializer test checks it. If that is okay and matches, then it generates the byte output of this and feeds it back into the driver. And then, well, in this case, it's a simple request response thing. So in the end, the request would be finished, and then PLC4X would respond with an API response, and I would get my PLC read response with the original request, and here's the PLC value. I think it's a very generic way of defining these tests. I think, of course, Java 1 is the only one using it right now. So perhaps getting rid of this might be a good idea. I have no idea. I think we just need to try it out. But I think it contains all the important stuff you need to test drivers in any language, because besides the package names, there's really nothing tying it to Java. Does that explain things a little? And
yeah, sure.
So what I wanted to do was to write something that sort of like has a look at this block of XML and produces some C code that, for example, just checks, is this this type? Does it have, is the payload property set to this? Does it have 3 parameters? Are there types this? So I could probably just generate some static code that just checks this. And that was what I was thinking of. Because
and
I think
that's because you want to avoid writing something that writes out to XML.
I think from what I had a look at, I think writing something that reads and processes XML in C is sort of a nightmare.
If we take a step higher, the Java framework that runs these test cases does not exist in C, and you don't want to write that. That's the point.
Yeah, well, most of it already exists, because just the serializing and parsing stuff, that is not really a problem.
But this thing that orchestrates the send message, get the thing that
this stuff in Java, I just ask Jackson to create an XML representation of this Java object, and I get this blob of XML, and I could just use XML diff to sort of like do a diff of these 2 XML blobs. That would be challenging in C, because there is no sort of reflection. I would have to sort of build something that produces an XML representation of my C structures. And I would say that is quite challenging. Or do you not agree? I could probably create an extra, what I could probably do was to sort of create an extra template, Freemarker template for every type to sort of like produce XML and have that just generated to test. Might think of that. So I have one that serializes my object structure to bytes, and one that would produce XML from it. So that, yeah. I don't want to scare you.
If you could change this to JSON, I know a really good C JSON library, which wouldn't be such a pain to work with. But that might be a bridge too far.
JSON was the thing that allows comments, wasn't it?
JSON does not allow comments. YAML would allow comments.
That is so stupid, because I think comments are, especially in those test cases, I think I didn't write too many of them. But in general, I think it would be a really bad idea not to be able to write comments in my test data.
Yeah. Well, I've done something similar to what you have here in C. Although it wasn't for testing, I took a PCAP and parsed it out into like a script of reply and response, but outputting the buffers in a nice readable and editable format in JSON. And then you could replay that on the client side or the server side to take a PCAP and simulate the traffic.
Okay.
I mean, you could use that type of approach to validate the test data. But honestly, I don't think we should rabbit hole on this. I think if I wanted to think of a different way to do it, I'd probably want like some kind of, I don't want to say bug report, but some kind of JIRA issue or problem statement that I could think about a little more. Whenever I hear, I think I'll write a new language generator to fix this problem, so I don't have to do XML.
Yeah, well, generally, I'm a big fan of XML. I just sort of like in the past I did everything with it, but just in C,
you like writing like super multi-line regexes too while you're at it?
No. Yeah. So in the template files, you have to sort of like you see these with a what's it called, the hashtag hash sign. Those are Freemarker comments. So this is just the normal Apache header. So what I said, the first line of the output, that defines the name of the file that will be generated. So yeah. So
Chris, have you ever used Velocity?
Yeah, I didn't like it that much.
I just from the point of view that I've used Velocity before, and you use Velocity if you're gonna write a Maven archetype, right? You're using Velocity to generate that. I just wanted to know, is this substantially different? Is Freemarker a lot different than Velocity?
No. I think I used both in the past, and I found Freemarker to be easier and more flexible and more powerful.
But conceptually the same?
Yeah.
Okay.
I think the only reason the Maven folks didn't use Freemarker was Velocity was an Apache project, the Freemarker wasn't. Now it's also an Apache project, so oh well, now it doesn't really matter. So when I was using both, I really liked Freemarker a lot more. But in generally, it's not much different. Here you can see the helper. That's always the Java language template helper. So I've got a lot of come on. Usually it knows, because I didn't declare the type. I did all of that in, let me go in here. Okay. So I did all of this to sort of like just tell Freemarker the types of everything. So you can jump, get code assist and stuff like that. So let us just have a look at this file. Okay, this was to have it not escape everything as if it was HTML. So this is my mouse stopped working. So I always generate the file name, and then I just start writing pure text. And everything you just write here is just gonna be output into the file just one-to-one. So I've got this static stuff here, and then I've got some dynamic stuff, and that's always with these $sign and curly braces, or with the orange parts with the pointy bracket and the hashtag, the hash sign. So this is, for example, only if this is sort of a discriminated parent type definition. So if this is a parent, then it generates this block. So just don't think too much about what actually all of this does, because it was really, really difficult to get all of this stuff working. And I think for Python, it's going to be a lot easier. So what you could do was sort of like, you just start writing a Python file that looks the way you want to, and then you just sort of like copy it into that template, and then you just replace the static parts with some expressions. Yeah. So I could open one of these C, and that's in here because. So let's have a look at this. So you can. I could sort of, you know, how to sort of split the tool, split horizontal. Okay. So now I've got the generated code here, and here I've got the template. So you can see here the stdio. Here comes the type name. I call this camel case to snake case because in MSpec everything is sort of like camel case, like in Java, but C likes it this way. So I've just created this little function to translate it into this. Here come the constants that are used for discriminated types. This is what this part is. I also added, I think nobody else ever added so many comments to generated code, but I think I wanted people to also understand the generated code. So this is sort of like, I think you can see that it represents what happens here. Then I have discriminator values, all of this. It's sort of like pretty trivial, I think. Or
We could always run ASCII doc or Doxygen against the generated code after we generate it and produce documentation for the
Sure.
specific driver, right?
What? Generate stuff from generated stuff.
Yeah. Or I mean, or we could that's interesting. How would you create a source distribution for a specific driver, for example? It would,
Well, the cool thing is, usually you wouldn't. Yeah, well, if you do a normal Maven build, it always creates a jar file. And if you do a release, it also does a source jar. And this source jar automatically contains all the generated source files.
right.
So, yeah. So that's, in Maven, that's already covered by the tooling.
Yeah, I don't know how that works with generated code though.
Yeah, it just packs up. Maven knows about all the sources, and it doesn't really care if they're sort of like generated or not generated. It just has a list of source directories, and the jar plugin, if you create a source bundle, it just takes all of these directories and just packs them together.
All right.
Yeah. So, any more questions to that? Okay, so now that you've sort of like going back to, I'll just stop sharing screen, then you can go.
So the first couple of goals would be to get the framework working.
Hmm?
Wouldn't implementing any specific driver other than a sample driver be like a follow-on?
Sure.
So instead of just rolling into Modbus, maybe we could just write an example.
No, I didn't. I just wanted to show you sort of like because I wanted to show you a simple driver, so I could sort of like show how it might be a good idea to sort of like start implement, because you will have to sort of like define a framework with which you can easily define logic. And if the Python logic would sort of somehow fit in line with the Java version, or sort of like not be too much different, we might in the future come up with a code generator for the logic part, and then we'd be able to sort of like switch both to generated logic.
Well, I think it should be clear in Lucas's notes that the next step in the steps that you're reading out isn't, okay, when you get this far, you start implementing Modbus or something. It should be, when you get this far, you're going to need some kind of driver, and maybe we write a sample driver
Yeah, sure.
instead of, paging in a real protocol.
Yeah. Okay. Yeah.
That's all. I just want to make sure the notes were clear.
Yeah. So here in this Modbus example, for what the interesting part is for example this. So we create these are the object types that we created in MSpec. So this Modbus PDU is something MSpec generated. We create this packet and then we send it. So this PDU is then sent to the wire, whatever transport we're using. So, and then it expects a response. It's nothing how to handle errors. And here it tells the system which is considered to be a valid response for this. So if there is a Modbus packet coming in and its transaction identifier matches the one I sent out, then this is the response to the request I sent up here. And in here comes the logic, what happens with that packet. So if you start implementing some sort of framework to implement drivers, it would be good if it was somehow down these lines, sort of like create a packet, you send it, you register a callback or whatever to handle the response. And if it was structurally similar, it would make creating a code generator for the logic a lot easier. Because if we had that in the future, we could really, everything we would need to create a new driver in C, for example, is just to sort of like create the MSpec and the other spec for the logic, and just create two empty projects for that, and it would just generate the driver. Ideally.
It sounds to me like you just would rather program all in XML. Because that other spec is going to look a lot like programming in XML.
Yeah, I did. I think you hadn't joined the project when I did